go. Who's joining? Oh, Michelle's here. Excellent. Welcome everybody to this Inca webinar, Designing the Gigabit Nation. And as I'm talking, I'll turn my video on. We can see the agenda on screen. We've got quite a packed agenda today. Lots of very interesting presenters and discussions, and chance for Q&A as we go through the session. But this is really a chance for us to see and hear from some of the key players in the industry as we start to scale up the deployment of digital networks in the UK. Network design and the pieces that influence network design becomes ever more critical as we go through this, and we'll hear from a number of speakers alongside that. There are a bunch of developments that have kicked off in the UK in the past sort of 12 months or so. Some interesting developments on design, on wireless approaches and assets, and we'll also be hearing from DCMS. Many of you have already heard from them yesterday and last week on some of their sessions. So this is a chance for a follow-up. And this is I think it's the second in our Gigabit Nation. We've got a final one coming in September, I believe, which we still need to put together. But without further ado, I think we can kick off with our keynote speech, which is from Huawei on Gigabit design. So I'll hand over to Arthur from Huawei to kick off your piece. Arthur, over to you. And you're on mute, Arthur. You're still on mute? There we go.
Thank you.
We can hear you now. Thanks.
Okay. So hello, everyone. My name is Arthur. That will be my true honor and the pleasure to do a 10-minute presentation about the fiber network planning. In the past decade, actually, my job is about the global support for the national broadband development. So in such a short time, it's no way to tell the complexity of the network design and planning. So I would like to focus on some of our idea sharing about the best practice from the global. So as you see that we will focus on the terminology so-called converged network grid. The convergence is quite important. And first of all, we would like to take a quick look on the recovery plan for the Europe. So I think everyone knows that in May, the EC has released this plan. And by combining with the policy of the European Gigabit Society and the guideline of a very high capacity network. So we do believe that the entire EU is now moving toward the full fiber. So it's perfectly aligned with the UK strategies. So when we're going to realize the full fiber nation, actually it's quite challenging, right? So by our study, you can see that by far, we can see that it's roughly 4 million FTTP coverage has been done in the UK. And by our forecasting, by next year, the capability to deliver the FTTP is probably 2.2 million FTTP home pass can be rolled out. If we want to realize a full fiber nation, which means that to provide the FTTP coverage to roughly 25 million Britain households, definitely the entire industry should deliver over 3 million FTTP, a new FTTP by 2022, and at least 4 million FTTP coverage should be done annually during the 2023 to 2025. So by this condition, we can also observe the other major stream happening during the lockdown, or we can say the during the pandemic, that will be social distancing. So a lot of stakeholders in the industry, they believe that the gigabit broadband connectivity can be provided by fiber, by 5G. So we can see that 5G is getting popular. Even in the UK, the 5G is take off to do a massive deployment. However, by the features which will be offered by the 5G, we believe that the fiber would be required to do the backhauling and over the fronthauling. The features of the two features of the 5G would be the ultra low latency and the ultra high reliabilities. So back to the right hand side, we can see the bar charts. Okay, the bar chart is talking about, is telling in global, it's about 47% of operators. They both have the fixed and the mobile access. And there is the highest rate in the Western Europe. So what's the message we can have? It's about the conceptual future-proof access network is come. So we can see this diagram that in the near future, it could be a kind of a scenario that the entire mobile networking would be simply like the power network. So the power network is initially designed for the 100% connect. And comparing from the past, the most of broadband connectivity, when we are doing the network design, for instance, based on the coax or the copper, we are focused on the coverage only. But by our study, again, we can foresee that in the next few years, there will be some of emergence will trigger the entire evolution of a network design from 100% coverage to 100% connect. So there will be several elements, particularly for the 5G and so-called cloud computing. We can say the multi-access edge computing. And of course, there will be a lot of innovative access technology as well. For instance, those 3.1, or we can say 3.5, and so on. So lots of access technology will sustain the business opportunity and fulfill all of the demands from the industry, even from the entire UK market. So I say that this is a kind of scenario could happen. So it brought a kind of a trend of the fiber-based network planning. This kind of idea actually came from the East Asia. If you look into the Japan or South Korean market, it's not difficult to figure out that the network design, or we can say the network planning, is have gradually changed. So at the left-hand side, as you see that in the past, most of the network design or rollout is based on demand. So in the past, the operator, they strongly believe that by this way, when the requirement comes or subscription emerges, then we do the rollout. It could maximize the return on investment. But what if we have aware that in the near future, everything will be connected and all of the household, even the enterprise, will require the ultra-fast broadband, which means that in the future, it will be full connected. So by this condition, it's no doubt that we have to renew our concept of network design, which means it will be plan-based, just like the power networking. When the power company, they go to the market, they always think that every premises is definitely require the electricity. So by these conditions, there will be a new physics comes. It would be the network grid. So comparing with the power grid, almost the same. that what's the beneficial things from the network grid, or we can say that it's a plan-based network design. So firstly, when we do the massive rollout, that will be some of the advantages. For instance, we can do the big ones. And secondly, if we have a complete planning, definitely we can provide a feature of elasticity much more easier than before. Comparing in the past, when we do the network rollout on demand, it's kind of a passive, right? And when we do the plan in advance, it could be much more reliant, or we can say elastic, flexible, and so on. So definitely it could support the future things comes, as I say, that it's FMC, fixed mobile convergence. Okay, so here comes a question. What if the company or the enterprise I own or I run or I served is just a local operator, even with just a tiny startups? How can we play FNC, or what should we do to realize the so-called converged network grid? So here we have some takeaways. Firstly, we can see the step one. It will be a multi-year planning. So it can be separated into two parts. Firstly, we can take a look on the strategic planning. So there'll be three elements we would like to highlight. Firstly, we are always encouraging the cooperation between the operators, particularly in between the local operator with the nationwide, the FMC operator. So that's why we are keep saying that the FMC could be done, and it definitely happened in the next few years. So the strength of the local network provider, it would be kind of an assistant, or we can say it's a kind of a strategic partners of nationwide FMC operators. In the UK, we can say it could be a BT, or after the merger, that would be a Virgin Media with O2, right? So that would be a potential that we can initiate a new business, particularly for the 5G development. Secondly, to utilize the BT OpenReach, the physical infra access. So it is critical, even though that we still need some of help from the public sector, I mean, from the regulator such as Ofcom. But anyhow, sooner I think the physical infra would be kind of open access, and it will be significantly help some regions to lower the civil work cost. So that'll be the one. And the last one will be deal with the public authority as early as possible. So the reason is that everyone knows the major obstacle to deliver the fiber would be the civil work, right? And the civil work is always comes with a right of way. So on the one hand, it will be easier to sense the difficulty of retrieving right of way. And on the other hand, we can see the intention or the attitude from the maybe municipal officers, and to have better information to do a top level network planning. So for the second part, it was definitely about the network planning, such as top-down and disaster recovery, grid-based, and so on. For the step two, here is also an innovative idea about the marketing and sales. We call it proactive one. So later on, we will have a reference. Later on, I will explain for that. For the deployment, we are now seeing, for instance, in Singapore or in the Middle East, some of the developed countries, they are unifying the element spec, and including the SOP, to deliver the physical cables. And on the other side, the digitalization of the project manager and the rollout manager is also critical. For the step 4 and 5, it's talking about how to optimize the provisioning, operation, and the maintenance. So I think some of you probably can wait to see the references from the global. So actually here we have some of snapshot. Firstly, from the Bahrain, there is a major operator. Actually, they have implement so-called converged network grid. So what they have done is they redesign the entire network from the layer 1 to layer 3. And they also determine how to roll out the phase by phases. So by reconstruct the code aggregation layers, they can make insurance. They can ensure that in the near future, this network can accommodate all of the needs from the B2C, B2H, and the B2B, and etc. And it could be also eligible to do the wholesale business under the government regulation. So this is a live and active use case is now happening in Bahrain. In the middle, we can see that in the step 2, we have observed that there will be one Dutch infra developers. They have one of the scheme so-called prescription for the cash refund. So imagine that in your responsible region or areas, what if the subscriber, the potential subscriber, they want to have the broadband services and you can know it in advance. So that will be very effective to do what? To prioritize which area you should roll out the cable to roll out the fiber first, right? So by this way, that will be kind of a win-win solution. For the developers, we can aware and prioritize which area should lay the fiber in advance. Secondly, for the users, they can get some of a cash refund voucher as a return. So by this way, we can significantly increase the take-up rate when we doing the rollout. It can be happen just by a click. For the step 3, we have a third reference from France. So the digitalization of the rollout management has been done. Those 2 photos actually has been taken by myself. So you can see that one of the major operators, they have required all of the outsourced engineering team to implement the digital platform to manage their rollout, daily rollout by taking photos, by reporting where they are. Secondly, they also have a very interesting one. When they do the open access with the dust and the manhole, they have deal with each major operators by color. They can identify which tube is include the different wiring by different operators. So this is one we can refer from France. The last 2, the first one would be the zero touch provisioning from Switzerland. Okay, during the pandemic, when we got the lockdown policies or measures, so it's very suffering for the field engineer to knock your door and get into your houses. So we so-called it's a GTP is now commercialized, which means that the operator, they can utilize the one of intelligent management system and simply mail a boxes with the terminals, for instance, the CPE, to the subscriber houses. Then the users, they can do the DIY by themselves and they initiate the entire broadband connectivity with the remote support from the NAC, the Network Operation Center. Okay. So because of a time limit for the fix, the reference actually is OTDR. I think most of you have aware that the OTDR is a mature solution to monitor the fault or any kind of defects over the optical fibers, right? So let's keep it. So to work up all the things I mentioned. Firstly, the full fiber is definitely on the right track to be realized. It's not only about the fixed business, but also mobile ones. So when we want to jointly do the full connected nation by fiber and over the 5G, we definitely need a network convergence. And the terminology, the grid, will be the one to gradualize entire network planning, just like the post system in UK. There will be also a grid system has been adopted by the post office. So by this way, we have seen the 5 approaches to digitalize the entire convergent network grid. So this is what I have delivered to you, and thanks for your listening. And hopefully that during the panel discussion, we can do the Q&A. Thanks.
Excellent. Thank you, Arthur. Many thanks for your presentation. Okay, we're now going to move swiftly into a discussion from Lloyd on the Inca board on wholesale, and if we get time, a little bit of a discussion on access to infrastructure. So Lloyd, if you're there and can bring up your slides, then we'll move across to you.
I am indeed here. Well, I am truly mobile in every sense of...
Yeah, fantastic. You're in your car. Is that the only place you can get peace and quiet, Lloyd?
Okay. So what we'd like to talk about in this section under wholesale is really providing an update on what we're trying to achieve across the industry, particularly in relation to the independent network operators. We had a very interesting call with DCMS this morning. We've had a number of conversations with Ofcom, and what people need to understand, what everybody needs to understand, is there are 2 very significant threats to our industry, and that those threats are also significant opportunities. In terms of what can I just check, when I'm sharing it the way I'm sharing it, Rob, could you confirm, are you seeing the presentation without the imagery as well, just the presentation on its own, or are you seeing all the...
That's fine, Lloyd.
It looks
You're
good.
okay.
Imminent Ofcom legislation, full slide.
Yep, thank you. Perfect. So what we'd like to do really is just make sure that we're bringing you up to speed as to where we are. Within Inca, we've put together a special interest group to address both the requirement for gaining provider-led switching and the requirement for wholesale. And we're using those to work side by side towards a goal of achieving something that the independent network industry can now use to provide a gateway into their networks for everybody. So just to sort of highlighting the opportunities and what's happening, what the threats are. The first piece is the legislation from Ofcom around switching, and this is coming into place. This has moved since this slide was produced. It moved in the last couple of days. We're now looking at a decision in October from Ofcom as to which direction they're likely to take on the switching protocols. And once we understand that, we then have a year. We only have 1 year to bring that process online, okay? Gaining provider-led switching, you will no longer get a phone call from your former customer saying, I'd like to leave your service. Instead, you will get a phone call, you will get contacted electronically by a new provider who says, your former customer is now joining us. We need you to transfer their relevant details across to us. Likewise, if you win a customer, you will have the opportunity to do the same to another provider and say, this customer wants to use our service. I'm telling you, they're going to stop using your service from this date. Please pass all their details across to us. Clearly, that's not going to happen as a face-to-face conversation or a telephone conversation. That's going to happen electronically. And for that to happen electronically, there's going to be a lot of systems in place, and Inca recognize that most companies are not going to be able to produce the type of systems needed to support this process. So we are proposing a platform that is going to help and support this, and we're doing a lot of work towards providing GPL support. I think the next slide on this one is also understanding how the legislation has changed from Ofcom's point of view, from the consumer, and how the likelihood that Openreach will have remedies put upon them that will encourage them to overbuild, specifically in Area 3, what's described as Area 3. Just to be clear about that, they are going to overbuild because Ofcom's position is the independent network operators cannot provide consumer choice. They back that statement up by saying simply that the majority of consumers in the UK are using services from the likes of TalkTalk, Sky, PlusNet, Openreach, etc. BT, I beg your pardon, etc. And if your network cannot support providing the consumer a service from one of those providers, then you are not providing consumer choice. Even if what you're offering is half the price, you're not providing consumer choice. The challenge we have is that we all know these larger retailers are not terribly willing to engage with the internet, with the independent network operators, because generally speaking, they claim the cost of doing so for each individual operator is just too high. You've got to be presenting hundreds of thousands of customers for them to be able to cost justify that process. So what we intend to do to overcome that is to provide the industry with a platform where everybody can present their network coverage to this one platform, and this one platform will then be the integration point for the rest of the industry to join. We believe if we present that choice and say to Ofcom, actually, we are not stopping the internet service providers from joining our network, they are just refusing to engage. That shifts the argument slightly differently. As part of this, of course, we will also try to get those people to engage. So what I've presented here is a summary of the type of issues that are being faced around SLAs, around handover procedures, around fault and customer service issues, provisioning rules, etc. So what we hope to address is on a single platform, a standardized process to address all of these issues. What we've done, and what hopefully most of you will recognize, is we've produced a survey as the next phase of what we're doing, where we're going to the industry and saying, look, we're presenting these ideas to you, but it's silly us going any further forward unless as an industry, you think it's a good idea what we're doing. So we put a survey out. We so far have had in the order of around 60 responses to that survey. And I'm going now to present the results to you as to what what the survey outcome was. The first questions we asked was how many of us within the industry were aware of GPL, gaining provider-led switching. And it was very clear that there was a large slice of the industry that prior to engaging in the survey perhaps hadn't really caught up with the impact of what GPL meant to them, and that it was going to be a mandatory requirement within 12 months of its launch that your business was able to manage GPL. We then asked, do you have any GPL plans in place? And naturally, with so many people not understanding it was even coming into being, there was also very few companies that had any GPL plans in place, which therefore doesn't come as any surprise to learn that there was overwhelming support for Inca to produce a GPL platform from which people could engage in the industry. It was also interesting to understand what people understood about the fixed telecom access review that's going on at the moment by Ofcom, and the impact that that would have on the potential overbuild if Ofcom decided that we were no longer, that the consumer was not being given suitable choice by independent networks. The outcome therefore would be that the BT or maybe perhaps Virgin, etc., would be encouraged, let's go with the BT rule, they would be encouraged to overbuild us because it would be remedies that would be applied to them, not Virgin, I beg your pardon. It's confusing issues. I think that it goes without saying, therefore, were people aware of this threat? And would it be a threat to your network if it happened? This is the key question for us. And there is a huge majority of people that think it is a threat to their network if it happens. And there is also a very determined core that believe they're indifferent towards that happening, and they don't care if BT get remedied to deliver a cheaper service in order to encourage them to build in your area. I think that's a brave choice for those people, but everybody's entitled to their own business decisions, clearly. So for those that consider it a threat, there's your outcome. When we then asked, were business interested in were you as a business interested in providing wholesale access? Again, quite a strong response to say that they were, and also a core group of people who said that's not our business model. We're going to be vertically aligned for our own services, and that's the end of it. We also challenged as to whether anybody was offering wholesale as it stood at the moment. Now, 30% of the respondents said they were. I would challenge whether 30% of the respondents have full wholesale systems in place, or whether they simply have some agreements in place for wholesale provision. We also were very keen on this question: was there interest in a common wholesale platform? And as you can see, very encouragingly, there's an overwhelming response that people are interested in what we're doing. And what I also wanted to do is just leave you with a slide that sort of highlighted two things. One, the network operators as a percentage of the respondents, and also highlighting this small area here, the suppliers involved in our industry, because if this affects us in the way that we think it really could affect us, it could also be affecting a multi-billion-pound supplier industry. So we believe the stakeholders in this debate with Ofcom is far wider than just the network operators themselves. This is a substantial industry, billions of pounds invested, billions more pounds to come, and it's really important that we're well represented, and that the plans that Ofcom currently propose are altered in a way that recognises the influence and the hard work and the coverage of the independent network operators, and also recognises the amount of funding not only that's gone into the industry, but that is still to come into the industry. There is still billions of pounds left to be invested in this industry from the investment sector. So I hope that gives a summary of where we've got to. Alongside this, we've also been doing a lot of work with looking at the technical requirements for this. And we have representations from 4 or 5 companies who are willing to help and get involved in building the GPL solutions that we need, and leading on to the wholesale platform. So there's been a lot of progress made, but I must emphasize to everybody in the conference today, we genuinely need to understand your position. And we need to know. So if you haven't taken part in the survey, it's really important that you do so, please. And I think that what we'll do is, after this meeting, we'll make sure that this survey link is circulated to everybody that's taken part. So I hope that gives a reasonable summary of our position, and I'm very happy to now hand over to Rob to talk about ATI.
Excellent. Thanks very much, Lloyd, for that overview. If I can ask you to just post the link of that survey into the chat, therefore everybody on the call's got it. But obviously it's on the website as well. It will be in the slides when they get sent out. So those of you who haven't, just to reiterate, please take the time out. It only takes 5 minutes. Take the time out to complete the survey so we've got a fuller picture. So thank you for that. I just wanted to briefly talk about access to infrastructure. Trying to find the right screen to share. Hopefully you can see that now. This is in some ways linked, but it's just an addition here to something that is going on in the industry at the moment. So the access to infrastructure regulations have been out since 2016, were previously called the Broadband Cost Reduction Directive, and essentially are designed to make it easier for telecoms operators to reuse existing passive infrastructure, so ducts, poles, masts, etc., mainly from utility operators or any other operator that has something. What seems to have happened is that no one has really used it that much. There's a few people that have, and I think some of them are on this call, but no one's really used it in anger. And DCMS would like to know why, because they want to make it more useful for people to use it. So this is just an information slide, really, just to say that you know, get in touch if you want to be involved in this. There is a current call for evidence from DCMS ongoing until September the 4th. We are aiming to plan a session with DCMS to discuss it sometime in July, but we'd like to get those that are interested involved as well. So do get in contact if you wish. There are some opportunities. It could potentially help you reduce build costs, speed up deployment, but it's a double-edged sword at the moment, at least, in that if you're able to access someone else's infrastructure, then it applies that they can potentially access yours as well. So we just need to make sure there's enough protection in place for all of our members and all of the operators out there. That's pretty much it on that one. So I think we can jump back to James, perhaps, to introduce the next session. If I can get my slides back up. Actually, I think what I need to do is allow Nick to talk. So Nick, I've just turned your phone on. Hopefully you can speak now.
Yes, can you hear me?
Yes, we can hear you. That's great. Yeah. Okay, fabulous. So, sorry, I don't know where James has gone. The next session is, we have 3 guest speakers now. We're going to kick off with Nick from DCMS, who unfortunately then has to leave at 3 o'clock. And then we'll be followed by Ian from Geist and Jeremy from Obelisk. So, Nick, over to you, because I'm conscious time is short.
Great, thanks, Rob. So my name is Nick Bibby. I work in DCMS within VD UK, and I am part of a team who are designing the new outside-in program. So some of you may have come to our engagement events that we held earlier this week and last week as well. So at a high level, this might be familiar to you. But just come to give everyone a brief update of the program, where we are with it, and what kind of key timelines are for the launch of this program. Just for the benefit of anyone who may not be aware though, so the Outside In program is a new program coming from BD UK, and it is a program to subsidise the build of gigabit capable networks in the hardest to reach 20% of the country. So it in many ways has some similarities to the Superfast program that we run. There are quite a few significant differences. The number one being that we're currently only going to be subsidising gigabit capable speeds, and that it is going to be a central programme run by BD UK instead of being managed through the local authorities across England, which is how the Superfast programme currently runs. We're currently at the stage of finalising our internal business cases for the programme, so we're taking that through the governance that we have in central government, as well as getting to the point of having our first draft of the contract, procurement documentation, and supporting guidance around that. So anyone who's been to our engagement events, we're going to start to share those with the suppliers in the market who we work with. So we're moving out of a stage of having a high level policy to try and beef out a bit more how the program is actually going to work on a practical level. And so as we progress through the summer, we're going to continue our market engagement to make sure that the program, as it ends up, will be something that can work for the market, as well as meeting the some of the quite challenging policy objectives that we have as part of this program. It's important to note that we're planning to launch this formally in the new year. So in January, we're going to be launching the DPS, which is a dynamic purchasing system, which is how we're going to run this program. So it works broadly similar to a framework contract and framework agreement. So we will pre-qualify as many organisations as we can in January, with the first intervention areas to bid against to be released in May next year. So what we're hoping to do over the rest of this year is bring everyone up to speed on the detail of how it's going to work, what the requirements will be for organisations to take part in the scheme, so that when we come to launch the first intervention areas, there's not too many questions about how it's going to operate and what counts as eligible. We are still working through finalising the full state aid notification as well, so this will still be a state aid funded programme as Superfast is. That's being drawn up at the moment. Once that notification is ready, that will detail all of the requirements from what a technology has to be able to do, how we class it as being gigabit capable, and we'll also cover the detail of any wholesale access requirements that there will be. Our expectation is that these will be at a very high level, broadly similar to Superfast. They will not be the same, but there will be some changes. But it will be similar things that are in the Superfast state aid notification that we expect to see in this one. So hopefully, if any of you are familiar with the Superfast programme, this won't be too much of a departure from what you're used to on that scheme. It will be also still be a investment gap funding model. So the way we award the grant subsidies to, because this is the least commercial part of the country, it's to subsidise the cost of your build, so that it's not a loss building in these most rural parts of the country. There's a lot of work as well going on in identifying the final list of what we call the F20, so that's the final 20%. We're still working through that at the moment, but over the next few months we will begin to share some of our assumptions with the market more widely, and this is so that we assure that when we're releasing areas for intervention, that ourselves, our policy assumptions match up to the real world and what the market knows. So we'll begin to share that, and also share what we propose are the draft first intervention areas, so that we can before we actually release that formally through an OMR process. So that'll be happening over the rest of the summer and the autumn, at the same time as we're engaging on the contracts and the guidance materials that happen that sit alongside this programme. As Rob said, I've got to dash off at 3, so if you have got any questions, please do submit them and we'll pick those up offline. But at a very high level, that's where we are with the programme, and some of the main differences, and fewer speakers to speak. So hopefully that's useful. But as I said, if there's any other questions that you want to know about, please ping them through, and I can get back to you via Rob. And I imagine that a lot of the attendees here may have attended our engagement events earlier this week and last week. So anyone who has, you'll know that we're going to be formally sharing a lot of this information at the end of this week, so in a couple of days.
Excellent. Thank you very much, Nick. I've just posted a quick message if anyone does have any quick questions to ask them now before Nick has to leave. But whilst people are thinking about that, I've got one quick one, and that's the notion of wholesale, which you did mention, and it relates to what Lloyd was talking about earlier. So how how much focus does BDUK DCMS put on the need for wholesale in the new outside-in processes that are coming up?
So any technology that's built would need to, there will be wholesale access requirements in the notification that comes through, and they'll be included in our technical specification as well. But it will be a requirement that we're only going to subsidise infrastructure that is compliant with our wholesale access requirements. I can't at this stage say exactly what they will be because they're still being written, but they will be a core part of the programme. And if a technology solution, obviously we have to remain technology agnostic from a grant subsidy perspective, but any technology solution must comply with the wholesale access requirements that will be in the programme. Again, they're probably going to be broadly similar to Superfast, but I can't say exactly what they will be because it's being actively written at the moment. But it will be a core part, so we're not going to award any kind of upfronts that doesn't meet the wholesale access requirements that will be in the eventual state aid notification.
Okay, thanks, Nick. James, any questions from your side?
I could talk about that all afternoon, that whole very sensitive issue about wholesale access and whether DCMS and Ofcom align and whether that's best for the market, but I don't think we've got time. So we'll need to pick that up another time. I think it's a huge issue that we need to be really quite concerned about.
Yep. Okay, let's move on. I think next up we have, so Nick, thank you for your input. You can by all means stay around for the next 10-15 minutes. We've got a couple more speakers and then we'll have a Q&A, but I suspect you would have dashed off by then. So thank you again for agreeing to present. We'll move on now and over to Ian from Geist to present from your side. Ian, over to you.
So can you see the screen there?
No, we can see your face, but nothing else. So you need to share a screen. There we go.
Okay.
Yep, there we go. Wonderful. Thanks.
Great, thank you. Thank you for inviting me to speak to this webinar today. What I'm going to present to you over the next 10 minutes or so is a range of services that Geist provides, predominantly to the planning and design phases of the FTT rollout lifecycle. But what we also provide adds value for subsequent stages of operations and handover. So you'll see those as we go through the presentation. Sorry, I'll just move this on. Oh, sorry, skipped on. There you go. So Geist as a business, what we do, we provide predominantly road and highway condition services to local authorities, central government in the form of Department for Transport and other utility companies. So as a consequence, we drive circa 200,000 kilometres of the UK's highway network in a year and capturing high definition imagery from which we analyse that imagery to provide data sets for clients predominantly on condition, but also on sort of surface type and other network assets. And we have a use case on what we provide in the FTTH market. For one client, we've done circa 50 cities already, something like 50,000 kilometres. So it is a proven model. And what I'm going to show you today is a number of sort of proposals and services that we have calculated can reduce the overall project costs of FTTH by about 10% and possibly up to 20% for what is effectively a minimal cost of about 60p to £1 per home passed. Obviously depending on volumes and locations, etc. These are not kind of made up numbers. That 10% is a proper calculation that we've done, which we could probably share. That's it's backed up by some sort of science and evidence and the like. And because of what we're providing is data and remote access platforms, all our data can be accessed and can be accessed online from the desktop, from home working. which allows for collaborative working and can mitigate some of the restrictions that are currently in place due to the corona pandemic. So it was a benefit that we previously used to state about, you know, working more effectively from home, etc. And obviously it's become more important in the last few months. So just a little description of what we provide and how it adds value to the whole process. So in the planning phase, what we provide allows for greater accuracy of business case development and forecasting, and also optimal route planning at a higher level for minimum cost and maximum speed. And we also allow for the validation of existing network assets, particularly PIA. And I'll also show you something that we've recently brought to the market as an innovative pole solution. It mentioned, just referring back to your previous slides about the ATI, I think what we can offer helps that. In the design phase, so our data helps to provide more detailed information in scoping and preparation of the projects to help minimise variations, project overruns and aborted visits. They say all the while reducing walk-in surveys and reducing the need for MSVs. I'm not saying that, you know, we remove the need for walk-in surveys and MSVs 100%, but we can certainly save a large volume of that. And just in terms of the cost savings that I indicated earlier, I've kind of calculated that if use of our data prevents one aborted visit, it pays for its data in the first instance. And something that is relatively new, in May of this year, the fourth edition of the SROH specification was released, that now has a section in there that has a requirement that where footways are dilapidated, there is a requirement on the civils company to provide data on the footway condition and agree a solution with the local authority. And what we offer, obviously, is key to that. It's something that we are doing already for a number of local authorities. So I say if we add value to the planning and design phases, then moving on into operations, you know, using our data can help provide more detail in RAMs, documentation and construction phase health and safety plans, etc., to make you more compliant with CDM regulations, and thereby helping to reduce accidents and incidents. And then once the works are completed, our data and imagery can help improve as-built documentation, management of civils contracts, etc., and thereby reducing the incidences and management of any warranty claims that subsequently arrive. So what I'm going to demonstrate today are 4 products that we have that add value to this market. So Gaze Materials is a data set that shows you detailed analysis of the surface material of verges, footways and carriageways for the entire planned network. Gaze Carriageway and Footway is a data set of the current condition of that network and the existing damage. So we assess 35 different damage types and produce a condition assessment, again, for the entire network, entire length of the planned route. And that is the kind of data that we already provide to local authorities. So if any are engaging with some of our existing clients in that local authority space, it's probably our data and the imagery that they were using to plan and validate your works. Gates Assets is the tool that identifies and locates existing network infrastructure and its attributes. And then, as I said earlier, we do that by analysing imagery that we capture. So Gaze Vision are the tools that we can then allow you to have for follow and reference of any queries that you may have. So if there's a particular asset you want to have a look at, you can look at its source imagery. You can zoom around the working environment to get it into its context for looking at things like traffic management permits and things like that. So what I'm going to show you next are a series of screenshots from our tool Asset Stream of this data in practice. But what we normally provide to clients is the data in a raw shape file or CSV format for use in your own systems for your designers and your planners to use on a daily basis. So I say these are just screenshots. I can set up a live demonstration of the data if you wish moving forward. So this is a screenshot of Gaze Materials. So as I said earlier, it's saying We break the entire network, verges, footway and carriageways into a series of polygons and assign a material type to it. As its typical attributes are its surface area and what it's made of. This is, a screenshot of how it visually looks in a GIS tool, but it can also be provided as a CSV or spreadsheet format. So for each one of those surface types and areas, you can assign a cost and time attribute, and therefore you can massively improve the accuracy of your business case and budgeting and forecasting, etc. So this is the gauge footway condition. Again, this is what I said. This is what we currently provide to a lot of local authorities. You'll see again. So we've provided a polygonized condition map for the entire area. You can't really see on the screen there, but the type of data that we provide. But we grade it 1 to 5. We analyze 35 different defect types to produce that condition report. So grade 1 being really good, grade 5 being in urgent need of repair. And the comparison on the right there is typically what is used for walked out surveys, perhaps taken from Google Street View or something like that, or by a surveyor, a photographer at one end of either end of the street. What we provide is a condition assessment of the entire length of it with supporting imagery of the entire length, a bit like Google Street View in that scenario. So we do capture a range of network assets, including chambers, cabinets, and other network assets. But what this is a screenshot of just poles only. This is relatively new for us. So we locate and identify the attributes of all telegraph poles. You can see this one that's highlighted here. It's 4.36 meters high. The number of connections from it is 12. The type, we can also look at condition and deflection, etc. But what we can also identify is where each one of the drop wire connections go to, which property they go to, what the span length is, and all that is done by analysing imagery. And then back to that, so you have these data sets, and as I said earlier, that your teams and your guys and your planning departments can have reference back to the source imagery. So this is for a particular area of Newcastle where we've done a project. So we have the 5 camera views there. You can see the level of detail. It's something like 900 times greater resolution than Google Earth. And on this particular one, you can see there's been some trenching works to that pole and then down the pavement there. So that can be used then for validating works before and after, and I say managing claims. And you can see the sort of level of image quality, resolution on that particular works there, going down the pavement and into the property. Again, same with some existing chambers. So that is a summary of what we offer, and again where we add value to each of the 4 phases of the rollout process and the benefits that each one provides. So as I said earlier, this is this is not a concept. We are delivering these services to sort of 50-60 local authorities and a number of fibre to the home rollout companies already. We were successful in winning an award from Inca at the last convention last year, so thank you for that. So we're recognised for our innovation in reducing the cost and speeding up deployment. And the work that we've been doing in the highway sector, we've recently been referenced in the House of Commons Transport Select Committee for the innovation that we're bringing to managing the state of the public highway. Short and sweet, that's my contact details. I'd be more than happy to set up a demonstration of our live data on the system to show you in real time what it looks like and how it can be used and how you can use it in your own systems and follow up on any other queries that you may have.
Excellent. Thanks very much, Ian. Much appreciated.
Thank you.
We will quickly follow on. We're running a little bit behind time, but I'd like to now introduce Jeremy. If you're there, Jeremy Sheehan.
I am, yeah.
Wonderful. If you can,
does that come
look at
up?
that. You jumped straight in with SlideShare. Well done.
Okay.
Over to you.
Good afternoon, everybody. My name's Jeremy Sheehan. I'm the UK Managing Director for Obelisk, and I've been asked to just give a bit of an overview of designing and surveying and building fiber to the premise networks. I've got a few slides and I'm going to skip through them pretty quickly. I believe afterwards there'll be a link to them somehow through Inca. So bear with me and let's see if we can get through this pretty quickly. Rob, perhaps you keep the time. Okay. Let's see if this.
Yes, no problem. Timing's out the window anyway, so crack on.
Let's page down. So we're a company, very briefly, doing design, build and maintain. We operate in the telecom, power and renewable energy market, operating out of Ireland, UK and South Africa. And in principle, we design, build and maintain networks. And today I'm really just going to focus on fiber to the premise, which is a big play for us. We've been in that market for a few years now. And let me see if I can go down. So we have built in the region of about 45,000 connectable homes. And I use the word connectable because our mantra has been around the fact that a lot of homes are passed but aren't connectable. And the design element should be, in principle, a connectable home. And the sort of basis that we use for that is that it's within about 150 meters maximum of a connectable pole or some sort of pots on the ground. The other key thing is you should be able to deliver against a forecasted delivery on a per quarter basis. And currently we have over in excess of 20,000 homes either in design, survey or being built. And hopefully you'll see a lot of pictures and you'll see what it is that we're challenging ourselves with and the market is in the UK. So I think the key factors to start with are associated with coverage, asset reuse and a detailed survey. I put the word coverage in there because actually there's a great variety of how to optimize a design, be it on price or coverage. Obviously, if it's an intervention network, then you're quite often told exactly what to cover. And as we know, the hockey stick at the high percentage increases disproportionately regarding a cost per homes passed. So that's one of the key things I'll be talking about as we go through. Obviously, it's also associated with the ability to deliver, so asset reuse. What we are finding is that in principle in the UK, people are estimating or trying to forecast between 45 and 65% of PIA reuse. We're starting to see that on the high level design that we're putting together. And we're seeing that because it's driving substantially the cost of delivery of the build down. We have actually also been working on designs which is 100% PIA. And when I say 100%, I really do mean 100%. And the only new civils is around aggregation chambers. However, the key thing though, regardless of the design, is the design is no good unless you have good survey data. So you need to be able to understand that, and you need to have a good understanding so that you can actually come at the point of when you want to build it, you know you can build it with confidence. So this is the flow. I won't go through each line item. Of course, we've got to get the data. We've got to understand where it is that we're actually designing, level design, build survey. We're ultimately trying to get to the low level design and optimizing that design ready for approval. And then actually driving from that data, the build pack and an as built. And what we've done internally actually is over the end of last year and the beginning of this year, we brought in-house our design capability. And you may have seen one or two announcements on LinkedIn. We actually chose a company called Dipro. Delighted with that decision. It's enabled us to, along with our own systems, have a fully integrated system on an IT platform right from the beginning to the end, including as-builts and all done on handheld data in real time out on the survey and in the build. So One thing I thought it'd be worth mentioning is the type of skill set actually that's required. Of course, we need some design engineers, normally fully trained with systems and experience gained probably from an operator. Some of the big operators, of course, the incumbents and so forth, various levels. We have a particular design manager who does the interface to the client and allow the designers, for want of a better word, in the back office to actually get on and do the job. And then we got surveyors. The key thing around the surveyors are they're fully trained. They're obviously experienced in fiber to the premise networks, overhead and underground, PIA certified, because otherwise we need to be compliant with that because of the way that the design is using existing assets. And quite often, or nearly all, in all cases, the surveyors are the mixed team with the build. So again, they are multi-skilled. We've even put our own build team who are PIA trained onto splicing courses, not because we necessarily think they're going to be doing splicing, but because they need to understand what's required to actually build it to cost and to time once we get the pack. So there's no point understanding to do a survey if you don't understand how you're going to build it at a later date. As we know, we're looking at a client to contractor defined geographic areas. We're looking at the different levels here. So on the left-hand side, we've got the defined area. We're starting in level 2 to understand where the polygons are and what areas we're going to associate with that. We understand where our POP or our exchange is. And then, of course, we're starting to break down each of those areas, and we move right the way down to the street level. That's all integrated into the system. The system is set up with technology that's being used by the operator. So all the technical specs, how it's installed and so forth, and where it is, so that we can then actually start to design the fiber along with the survey data into a fully spliced understanding of a as-built set of documentation. I'll nip through this. So this is a real live network that we're currently looking at. So top left-hand side, you can start to see the spine distribution that we've been designing. It starts to show the topology of the network. Left-hand side, bottom left, you're starting to see the polygons. We've noted the areas, we're starting to reference them. And then on the right-hand side, we're starting to get into the detail of where we think some of the access chambers are that we're going to put in ourselves, and on the aggregation to see what we're going to do on that. As we move further forward, we've got the overall high-level design. We're starting to this is all uploaded into the cloud, into our own systems internally, and then we're starting to push it onto the surveyors. So the surveyors operate a number of handheld devices, some simply on phones, some on tablets. They're getting real live data, and as they take the photos, and I'll show that in a minute, all the information that's coming through is going back into the design tool, and in the back office, actually, as that data is live and coming through, you'll find that the design team are going back, sending messages back to that tablet or that phone saying, picture's not high enough quality, you haven't done this or you haven't done that. Quite often the system actually doesn't allow you to send it unless you've answered all the questions as you've gone through. What we're trying to do here, though, is to understand as a weekly basis, where are we? So how do we report back to the client? We're showing them that what we've surveyed. We're showing them the number of houses that are covered from that recent survey on a week-by-week basis, assets, poles, chambers, where we are on the program itself. And on the bottom right-hand side, you can see at the beginning of this, before we took over the systems of bringing them online, we were doing it by maps, by hand printed maps. And of course, it's fantastic when the weather's good, but awful when it isn't. Some of the photos that you're beginning to see now on the survey, it's quite interesting when someone decides to put their garden fence across the top of a manhole. Not always easy to deal with. We're starting to see flooded chambers, large flooded chambers, And we're also seeing locked boxes. Now, this is on BT's PIA assets, but it gives you some feel of the type of information that we're gathering, so that when we get to the build stage, if we need to use that asset, a lot of pre-work is actually done. Here we're starting to see where do we need to place some of the aggregation chambers, and how do we do that. This is very early on in the design. This is probably a little separate team has gone out. They roughly know where we've got to place them. We're starting to understand what the difficulties are, local authority permits and so forth, and whether it's feasible, and whether that type of deployment starts to cost in, because in principle we're trying to optimize the design, and we're trying to run it on a ceiling price per homes passed basis across the batch of homes that we're looking at. Wanted to show you this. This is not untypical now. This is starting to see where you're seeing the reaction of BT Openreach to surveying work. We've seen this more than once now. So we've been out surveying. People start to notice us. We've been challenged by local authorities, especially over COVID-19, and we've also been talked to by BT Openreach, who've come along to check that we've got the right certification and so forth to do the survey, which of course we have. But we're starting to see that actually some things are changing after we've done the survey. So just because you've done the survey and you've uploaded it into the design platform, it doesn't mean it's going to be like it when you come to build. And I would say that the difference between survey and build is a critical point, because what you're starting to see is a reaction against the AutoNets, for whatever reason, and now it's not the time to discuss that, but you are seeing a change to that asset in between the survey and the design. So there's always a review going back a little bit over what we've done to see if it's changed, but it does cause some pretty interesting challenges as we move further on in the design. Here you're starting to see the amount of premises covered, how many we've looked at, how many homes are covered. We know where the exchange is, and we're starting to really focus in now on the beginnings of the low-level design. The database itself, the general process is looking at the exchange, where we're going to start to feed the fiber the feed to the splice points, the distribution, the ODP, and where the home is. And in principle, we're looking at, we're always trying to use existing assets if we have permission to do that, or we're trying to then optimize the design against being on the verge, the footpath, or the main carriageway. So this is typical of the information that we're getting. So on our handheld, we're looking at the pole itself. We're taking pictures of that. We're looking at the condition of it. We're looking at the size of that pole, because it will determine what we can actually connect it to later. And then, of course, we're looking at how many homes is that actually connecting. So it's surprising how many are being connected off one pole in very dense urban. And then, of course, we're looking at the chambers. So now we're starting to see the low-level design being placed back into the system. We know where it's connected. We're starting to understand the feeder, the length of the cables. We're starting to look at the splicing matrix and the technology behind that, and we're starting now to put these back into the system as a potential final low-level design. When you move across the map, be it on the systems, of course you can pull up. So if I hovered over where that lamppost is in the middle of the picture, serving those homes, it will give me all the data. It will give me the data that was surveyed, all the photographs, all the information I require. And then as we go through to the build stage later on, it will have a complete catalog of all the information affiliated with that up to the connection point, so that it's on an as-built network and database ready to hand over to the client. I apologize, I'm skipping through this quite quickly. Here you're starting to see the final push. We're moving into the build stage now. We're now connecting it and building it as per. What's interesting though is if we do find that on the build day, that we're actually on the building day, we have issues, we run a hotline back to the design team. We come up with a solution, and if possible, they do the redesign there and then, send it back as part of the handheld information that DigPro holds for us on the systems that we use, and then we can continue to build. This gives you an understanding of a few things. Top left-hand corner, here we're building a PIA network. The top left and the bottom left, we've done 3.5 kilometers of fiber aerial at this point. We're now going to come down the pole into a duct at the bottom, into a chamber. We're going to go across the road, and we're going to pull up about 2 kilometers, various chambers, up on the other side of the road as part of a rural intervention network. And on the right, this shows you actually in Ireland, this is where we've delivered, we've designed and built a fiber to the premise network on a power network. So this requires an outage. So it's quite interesting. So you designed it, you're ready to build it. And at this point, you need to forecast about 3 weeks in advance for an outage between 10:30 and 3:30 in the afternoon. And it is only at that window that you have the chance to actually deliver. So everything has to be orchestrated for those hours worked, because you cannot then go back for another outage on that network. Left-hand side, this is a civils position. This is a network in the UK, a recent network. You can see the type of planning required. This is a major road, A-class road. Of course, the design, in this case, we haven't designed it, but in this case, we have planned it. So we've been working with the operator. We've been looking at the design, we've walked it, we've surveyed it, we've committed to the dates, and we then got the planning requirements with the local authority to close the road for a limited time, and now we're actually digging. In the middle, it's a power network. We've got an outage. We've got a rigger there, a climber there, putting the fiber on. Top right-hand corner. This week, we're just starting to fiber the cabinet. So all of that is on a sort of a turnkey basis. So the planning of that is critical, and the information that we're collecting from that and the way they report it is a big change for us over the last 18 months, 2 years, where we try to put everything now into the capability of IT, handheld devices, and so forth. The last thing worth noting is in our designs in Ireland, we've used a lot of facades. So yes, we've done overhead, yes, we've done ducting, and we've done new civils, but we also use facades. So in principle, we're running cable along the front of terrace housing. We're consenting, so each house needs consenting, and then we're running fiber across that, pulling back the fiber, and then delivering that to the home. The last thing is, of course, we want quality. We want to understand what we've done, how we've done it, how we've done the testing. Of course, we're doing the slicing. It's all on an app. It's all thrown up into the cloud on a real-time basis, and all the records are there ready then to verify and then hand over to the client at the end. So this gives you an understanding of the design tool. Again, very pleased with what we've done now and implemented with DigPro. So this gives you an absolute end-to-end understanding of where top left-hand side, all the relationship.
we do need to try and keep to some semblance
Okay.
of time. You're well
I
over
will
double
stop.
your time now.
Yep. Okay. I'll stop. Thank you very much.
Okay.
Thanks, Jeremy.
Do we have any questions related to those last couple of presentations? I think Nick has already gone now.
I think Nick is still connected by phone, but may be able to answer. But Nick, if you're there, just shout. But I think you're still connected.
Okay. What I suggested we go to the break and have a very short break. We've got a short video from one of the sponsors that we need to show. Hopefully it'll work better than the previous one, at least the sound will. And then we'll get back. So if we can, our timing is going appallingly off. So let's try and get back by 3:30 and get going by then, if not before. So let me see if I can have some more luck playing this video than I did last time.
For the past few years, FTTH network design automation has proven itself in the costing phase of projects, as well as for high-level design. Setting Star has allowed our customers to evaluate the budget of the project or to respond to calls for tenders for the deployment of fiber optic networks in many countries. Moreover, looking at the full scope of network studies, Setting Star is the only software that allows you to switch from preliminary to detailed studies in a natural and integrated way. Whatever your project is, Setting Star will allow you to define the network architecture, engineering rules, and all its specific constraints to benefit from the power of automation while enhancing the expertise of your teams. In essence, Setting Star is a software that plans up to the fiber and allows optical routes to be designed in detail. An integrated map with the right business-oriented tools, allowing you to modify the design in an interactive way. The fastest design software on the market. Thanks to this powerful combination of automation and human interaction, you will benefit from unmatched quality, better productivity, and cost savings. Setting Star has already been used by our customers to design millions of premises. To find out how Setting Star can help you with your projects, please contact us.
Just a couple more minutes for everybody to grab a coffee and a break, and we'll start again in about 3 minutes. James, do you want to run the video again?
Yeah, can do.
For the past few years, FTTH network design automation has proven itself in the costing phase of projects, as well as for high-level design. SETIC Star has allowed our customers to evaluate the budget of their project, or to respond to calls for tenders for the deployment of fiber optic networks in many countries. Moreover, looking at the full scope of network studies, SETIC Star is the only software that allows you For the past few years, FTTH network design automation has proven itself in the costing phase of projects, as well as for high-level design. SETIC Star has allowed our customers to evaluate the budget of their project, or to respond to calls for tenders for the deployment of fiber optic networks in many countries. Moreover, looking at the full scope of network studies, SETIC Star is the only software that allows you to switch from preliminary to detailed studies in a natural and integrated way. Whatever your project is, SETIC Star will allow you to define the network architecture, engineering rules, and all its specific constraints to benefit from the power of automation while enhancing the expertise of your teams. In essence, SETIC Star is a software that plans up to the fiber and allows optical routes to be designed in detail. An integrated map with the right business-oriented tools, allowing you to modify the design in an interactive way. The fastest design software on the market. Thanks to this powerful combination of automation and human interaction, you will benefit from unmatched quality, better productivity, and cost savings. SETIC Star has already been used by our customers to design millions of premises. To find out how SETIC Star can help you with your projects, please contact us. For the past few years,
Shall we carry on, James?
Yes, let's do that. So where have we got to? We're into the new technology approaches. So what have we got? We've got Andrew Miles. Andrew, are you there? Yes, you are.
I'm here. Yeah.
Look at that straight away. Fantastic.
Can you see what you need to see?
We can.
Indeed, yes.
Wonderful.
Thank you very much.
Brilliant. So I'm Andrew Miles from Blue Wireless. We're a millimeter wave technology company. So we do silicon, we do software. We like to think we can offer some expertise. Product design, perhaps not so much end product itself, but I'll come to that. So with Mark from Cambion, our mission is to excite a fiber audience with wireless, and to do that we need speed. So I've got just 3 slides. Hopefully that contributes. We also need plenty of spectrum. So millimeter wave includes band at 60 gigahertz, which is the band that I'm going to talk about. That's an unlicensed band. And one of the questions immediately you ask, perhaps about an unlicensed band, is so why does nobody want it? What's wrong with it? It gives you great freedom to deploy for anyone. What's the catch? So in 2.4 gigahertz, we've got to share it with microwave ovens. At 5 gigahertz, it's radars. 60 gigahertz is not so bad. At the lower part of this band, there's some oxygen molecular resonances that mean that links beyond a few hundred meters are a bit of a challenge. That's good and bad. It's good at short range because it means you can reuse the channel frequently. And at long range, it's more of a challenge. However, pretty much across much of the world, the regulators are looking at the top half of this band, which is free of that oxygen absorption, and that's already the case in the UK. So now in this band we've got the best of both worlds. We've got plenty of spectrum. We've got a lower part which we can use for links of a few hundred meters with good reuse, and we've got an upper half that we can use for links of 1 or 2 kilometers. The other thing that I should mention then about these very high frequencies is that an individual antenna becomes very small. That is kind of, it sounds like it should be a good thing, but the difficulty is that a very small thing doesn't intercept very much energy. So you either have to put it in the focus of a reflector to intercept that energy, or put a whole array of them together. The problem when you do that is that the antenna becomes very directional. So that's then what we've had to address through technology investment. So down here on the bottom right, there's a classical millimeter wave, I think it's just microwave dishes. Quite an interesting challenge for installation. They need to be on a nice stable mast, and you need a professional to align them carefully. What we can do with investment is create this thing, the picture here, of an electronically steered phased array antenna, and that means that the whole thing becomes much more usable. So the picture at the top is a deployment of about 200 sites that we did in Liverpool as part of a DCMS 5G testbed. And they could be deployed with ease on lampposts without any critical alignment. So how has that investment come about? Well, standards have had a big part to play in that. And there's in this band, there's been a healthy evolution of standards, starting with H211AD, which is what triggered the investment in technology and allowed us to develop our own silicon baseband. That's been picked up, that's been continued both in standards and in the industry, promoted to a large extent by Facebook with Telegraph. Mark knows a lot more about this than I do, so I'm not going to dwell on the standards evolution, but there's a healthy ecosystem. So coming back to that antenna then, that antenna means that we can do three things. We can install with relative ease because the antenna does the steering for us and the alignment for us. It means we can deploy point to multi-point multi-gigabit connections, and the challenge there is that to do a point to multi-point connection, you have to point the antenna at the other end of the link, and you have to be able to do that packet by packet as the link exchanges packets. So you need very high speed steering. And it also lets us do significant mobility. So my last slide, I hope I'm going to stay within budget and achieve the speed target. So the project we're doing with First Group exploits both of those assets. So we use the beam steering at speed to make sure that we can track at least 2 simultaneous connections to a train running at several hundred kilometers an hour. And at the same time, prepare or set up additional links to the next base station along the line or the next antenna on the train, so that we can make that connectivity seamless and continuous. So typically we're achieving 2 links at a gigabit each, and using that to serve a number of services on the train. Now here again, we're making life difficult for our baseband, but it's doing the job rather well, because if we want to deliver multiple services to that train, as well as maintaining the connectivity in this rather sort of challenging moving channel, we also have to maintain quality of service for the various services, including a kind of best effort service for the users on the train, which is making them very happy. operations on the train itself, such as point of sale terminals, but also we can support other wireless services on the train. So you could conceive of putting 5G small cells on the train moving at speed. So that's all I wanted to say. I hope there'll be some questions later, and Mark would be delighted to hand over to you.
Yeah, thank you.
Andrew, you probably need to. Thank you.
I will find the right button. Yeah, there we go. Right.
Hey, can everyone see my screen?
We can.
Okay. Hi all.
No, sorry,
video.
sorry. I beg your pardon. We can see you, so no, we can't see. I'm just looking at a dog wallpaper.
That one. That better? Can you see that?
Nope.
No.
Nope. Hang on. I'll tell you what. If I
Share the
turn.
right window. Yeah.
Turn that off.
It's looking. No.
No. How about now?
Nope. When you share screen, you need to pick the right window. So it's the PowerPoint presentation window that you need to share. Are you clicking the share screen button?
Yeah, it's apparently sharing the screen. Let me. Try that again.
That's looking more promising.
There we go. Perfect.
Oh, perfect.
That's it. Thank you.
Sorry, I'll make up the time. So, hi everyone. I'm Mark Jackson, a regional technical manager here at Cambium Networks. Today I'm going to take you through a new technology approach using our 60 gig SANWAVE product. Cambium's 60 gigahertz solution provides a way that allows real dense deployment of access in a city environment, a high density suburban and a rural market, allowing up to 15 gigabits phi rate with channel bonding. Although 60 gigahertz has a narrow beam, we allow for easy alignment and installation with auto beamforming. The 60 gigahertz products support mesh configuration, allowing for easy expansion and auto healing. As well as being software defined, we can configure multiple deployment options such as point-to-point, point-to-multipoint, and mesh. The product, our SANWAVE product, is 802.11ay based, and we embed Facebook Telegraph technology into the radio, and we will be Facebook Telegraph certified. Before I continue to talk about the product in more detail, one thing I want to clarify, as I already stated, the SANWAVE product is 802.11ay based. There are some 60 gigahertz solutions on the market already that are 802.11ad based. 802.11ay is a different standard. 802.11ay offers better performance and efficiency factors from the amount of CPEs per sector, throughput, deployment options, and the ability to use TDD synchronization. I mentioned about channel bonding, so let me just talk a little bit more about channel bonding. With the 60 gigahertz solution, we have 4 channels to use in 2.16 megahertz blocks. With channel bonding, basically by bonding 2 of those 2.16 gigahertz blocks together, we can double the capacity. So looking at this chart here, at the top, we can actually get 7.6 gigabits of throughput, which is 3.8 gigabits in each direction. So that's upload and download. Even at the MCS9 data rate, we're at 2.2 gigabits in each direction. So that's 2.2 up and 2.2 down. And at the lower end, at the MCS1, we're at 384 megabits. So as the further away you move, we can still provide quite a nice high upload and download speed. So to just reiterate, channel bonding will allow us to double capacity, and with the use of TDD and TDMA, we can actually deploy the channels on the same frequency. So using TDD synchronization, unlike standard 5 gigahertz channels, we only have the use of 4 channels currently. With 802.11ay, we can use TDD sync, which allows us to control when we send and receive data. So what we can do is each radio can be assigned a specific polarity. The odds will receive when the even send, and vice versa for each TDD frame. So by using TDMA and TDD frame structure, we can actually reduce interference in dense environments and achieve single channel operation, which will help us with the limited amount of channels that we have available. With the configurations, we can actually configure and we can support point-to-point, point-to-multipoint, and mesh. Mesh is a new configuration supported with 802.11ay, and we are leveraging the Telegraph technology for mesh support. People can actually start today with a point-to-multipoint setup, and they can migrate to a mesh configuration as the network grows. The use cases we see are wireless to the home for the providing high-speed broadband connectivity, wireless to the building for office and multi-dwelling units, rooftop to rooftop for point-to-point between buildings. It's ideal in the business districts, schools, and campuses. Fiber extension, which is that last stretch solution. Maybe you can get fiber to a certain point, but it might be a bit too costly to get it to every premises. And backhaul for smart city deployments, for Wi-Fi hotspots, cameras, 5G small cell. So if we look at it, typically what you'd see in a city centre deployment, you'll typically see a rooftop to rooftop deployment for your backhaul, and in a point to multi-point or mesh for the smart city type deployments. Your suburban deployments or your residential areas, 60 gigahertz can be used to provide internet connections. And this is an example is a mesh setup with multiple distribution and client nodes. But if you can get an internet breakout to one location, you can expand using a 60 gigahertz solution using point to multi-point or mesh. This is one of the industrial district use cases where businesses don't have fiber to the premises. But what we can do is we can allow you to go from that point of presence and expand out using the street poles, using the building tops. And that way you can connect to all the businesses without the need to do extensive and sometimes expensive building works to dig up roads, sidewalks, etc. I mentioned we can also do it for 5G small cell backhaul, but effectively with the 60 gigahertz solution, you can use it in a variety of different ways for point-to-point, point-to-multipoint, and self-healing mesh. You can actually deploy it as you need. So what is CN Wave? CN Wave is Cambium Network's 60 gigahertz solution, and it consists of a distribution node, which acts as an access point, but it can connect to other distribution nodes. The V5000 is a dual radio distribution node. We have 2 client nodes, which are the V3000 and the V1000, which act as subscriber modules, and they can also be used in a point-to-point configuration. Looking at the V5000 with a bit more detail, it uses 2 sectors, allowing channel bonding of 7.5 gigabits per sector. So that'll give you a total fire rate of 15 gig. Each sector is a 140-degree sector with beamforming. It's got low latency, less than 1 millisecond. Interface-wise, we have a 10 gig copper. We've got a 10 gig SFP plus, and we also have the ability to have a 1 gig copper, which will also do PoE out. So you can actually attach an access point of a camera into the bottom of this unit. The V3000 is our high gain client node and our 60 gigahertz longer range point-to-point radio. It can also be used in the point-to-multipoint and mesh configurations. With the same interface options as the V5000, it has beamforming with a 4-degree horizontal and 2-degree vertical, giving us up to 5 times greater than the standard 0.8 degree 60 60 gigahertz beamwidth. So using beamforming will allow us to have a much more stable connection in case of any movement in either direction. The V1000, this is our mid-gain client node. It's about the same size as your hand. It's a 1 gigabit radio up and down. It has a 1 gigabit port in it. So out of the three products, we have what's unique from Cambium Networks. V5000 is a dual sector design, making a simpler installation. You have choices of different client nodes from mid to high gain for the range challenges, along with beamforming for easy installations. 802.11ay based Teragraph certified product. Channel bonding capable for higher capacity. And you can manage it all in a single management platform. So if you use any of our other products, such as our CM Pilot access points or our CM Matrix switches, you can manage all the devices in a single pane of glass. We also have easy to use planning tools, along with it, such as CN Heat, as well as Link Planner. Thank you for your time. If there are any questions, please do not hesitate to ask. Or if you want to ask me offline, please send me an email. Thank you.
Thank you, Mark.
Mark,
James,
you'll need to unshare your screen, please, Mark.
I'm just
I think we can
to do that one.
we have
That's
time
it.
to do that ourselves.
Yeah.
Okay. To try and bring the times back to something approaching a schedule, I'm going to try and merge the Q&As together at the end. So in a sense, those who've kind of like missed the opportunities for doing Q&A earlier, then don't worry, we'll pick that up later. So please do keep sort of sending in your questions. Let's start to look at network assets then. And I see we've got Rob coming up soon, so I'm definitely going to try and get you to keep to time. But soon, first we've got Anders. Are you there?
Indeed, I am. Yeah. So I'm going to try to share a screen. Share. Is something visible?
Yes, it is.
Excellent. So, hello, I'm Anders Flodin. I'm the Swede of this session. Yes, we are the bad boys when it comes to COVID and so on, but I'm innocent personally. After saying that, I also want to say thank you very much, Jeremy, for an excellent presentation. I'm in charge of the product that you saw a lot of screenshots of in Jeremy's presentation. So what I'm going to do here, first of all, since you've seen 15 minutes of DigPro and DBCom already, I'm going to be brief. I'm going to be talking quickly about one thing. So that is the DP Wholesale, which is one of our products. So that's the wholesale platform for or a wholesale marketplace. And I think Rob is going to be touching a little bit more on not necessarily the platform in itself, but the use cases around it. But in Sweden, we have a system called Caesar that is run by SSNF, which is kind of the partner or a corresponding organization of Inca. And we're the makers behind Caesar. And that is conducting the majority of the business-to-business wholesale operations on fiber in Sweden. But then I'm going to talk about assets. I'm going to talk about networks and what you do with them once you're designed, and some good advices on how to design. So please, everybody, testify to our marketing department that you've seen this slide. And you have also seen, oh yeah, how do I, oh, that's the way to do it. And also on this slide, so it's a presentation on DigPro, what we are, we're about 100+ people. We're primarily Swedes, but we got offices in Norway and Poland. What is not in here is what we did a press release on a couple of days ago, and that's the partnership with Obelisk and customers here and there. Please testify that you've also seen this screen. That will make my colleagues happy. So one of the most important things I talk about when I'm out talking with customers and in conferences and with potential customers is the advantage of working with a proper model of your network, a digital twin. A representation of your network in terms of where it is, how it is connected, what are the hierarchies, pipes containing cables, containing fibers, the content of the nodes in terms of what kind of equipment, which racks you have, where they are, and how things are patched, spliced, and so on and so forth. Because that gives you the ability to do useful stuff with your network without necessarily needing to be out in the field. And for us, this means that the network model is the central point for the whole life cycle. So all the way from your planning up until the operation. And in this presentation now, I'm going to start looking at the operate phase. So the operate phase is the obvious phase where you benefit from a network model. This is where you can look at, okay, I'm going to do a reconfiguration because I'm going to replace a faulty cable or a cable that has seen its best days in terms of capacity. And who will be the affected customers? What kind of traffic is running on this cable? How do I get a hold of them? How do I notify them? What do I do when I get a feeling that I need to add more capacity in the network? Where are my bottlenecks? There is a new housing project in a part where I haven't connected yet. How do I do that? What can I reuse? What do I need to do anew? And so on and so forth. And all of that leans against a fully documented network in a reasonable tool. And a reasonable tool in my world is the tool I'm in charge of, but I can accept other tools in this whole world as long as they maintain a good model. Now, there are several ways on how to achieve that network model in the operation phase. And one of them is that you spend a lot of time getting informal as-built documentation into your system. And when I talk informal, I mean basically CAD files or other formats where you have the intention of making it human readable, not necessarily machine structured. So it could be very nice AutoCAD graphics that, as long as everybody understands what we're talking about, that the layer, so for instance, like that, the layer number 3 of the CAD file with the green lines, of course, everybody knows that that is the approximate position of the multi-duct 12s, and so on and so forth. But getting that into a full model takes time. So what I'm strongly advocating for is that you start being formalized as early as you can. So build your network in your planning phase, in your design phase, and also when you're building it. Build it in a well-defined format, in a well-defined structure. Obviously, I prefer that to be my tools, and as you've heard from Jeremy, it works well also in the early phases. But the most important thing is use a formalized tool so that you have an easy task of getting into your system and minimizing the deployment phase and getting into operation. Now, when you're in operation and you got well structured, that also means you can publish the assets you want to publish. And you can keep these assets updated in an easy way and publish what meet me points and shared nodes and so on, what kind of services are available, what kind of capacity you have, and how does that fit in with the needs of your potential customers. And with that said, I'm pushing the space all the time and realizing it's not working. I'm probably the first time in my life, perhaps on time. So with that, thank you, and hand over to Rob.
Well, fantastic. Thanks, thanks, Anders. Actually, we're going to hand over to somebody else now.
I need to stop sharing, and how the hell do I do that?
That's all right. I'll do it for you.
Ah, excellent.
We have the power. Thank you, Anders.
You're welcome.
David.
I think we need David. Yes.
Yeah. Sorry. Slightly abrupt now. You asked you need to go, but are you able to come on next?
I'd be delighted to. Somebody needs to enable me to do any video though, because it was been blocked.
That's interesting.
Interesting.
I'll ask to start your video.
Yay! There we go. Okay, I'm going to give you the fastest run through of anything ever, I hope. So I wanted to firstly introduce myself. I'm David Burns, Managing Director of Wireless Coverage, which I'm going to show you. I'm also the Chairman of the UK Wireless Internet Service Providers Association. We love working alongside Inca, so delighted and thank you for the opportunity to participate today. And I also run a fixed wireless network in the north of England with about 4,000 or 5,000 subscribers connected to it. So I do a lot of stuff with wireless. And what I'm going to try and do is share my screen, I guess, unless everyone can see what's on there at the moment anyway.
Yes, we can see it.
Okay, so wisdom, blah, blah, blah. With regard to wireless technology, newer technologies need faster speeds. If you want gigabit, you've got to use very high frequency signals. High frequency signals don't carry very far and they don't go around corners or through obstacles very well. So that means two things. One is any wireless planning needs to have very accurate data. And another thing is you need to have a lot of data, because if your equipment only has a short range of maybe 300, 400, 500 meters, if you want to cover a large area, you need to consider lots and lots of points along the way. So you need very high resolution data. Hopefully you can see see a funny colored blue and green blob on the screen. This is actually height data of a part of Britain at a resolution of 10 meters. Now, Google Earth uses about 30 meters resolution, and at 10 meters resolution, it's not really possible to see anything other than the fact there is some stuff on the ground. If you increase the resolution to 5 meters, so that's 4 times the amount of data, you can kind of see some forms emerging. If you go to 2 meters data, which again is like a lot more points, if you like, sample points, you can actually see now that there's probably some water. It looks like there are some trees, and it looks like there's some things that are in straight lines, which might well be buildings. When you go to 1 meter resolution, things start to look a bit better. 50 centimeters resolution, you see a bit more detail, 25 centimeters and so on. So we like to work in very high resolution data. High resolution data is really expensive, and it takes up masses and masses and masses of memory and machine resource and all that kind of stuff. And in fact, we've done work down to 8 centimeters resolution, but I regard it as being a complete waste of time, because if you ask somebody to install a piece of equipment on a property within an 8 centimeter tolerance, you're probably not going to be very successful. So we tend to operate a lot of things at 50 centimeters or 2 meters. And we've bought all of the data for Great Britain. So that's kind of helpful. And what we've done is to put that into a tool called Wisdom. We're a startup company. We built a front end for this thing starting about 8 months ago, but we've been working on the underlying technology for about 4 years. So I'm going to give a little taster. I think I'm the only person who's doing a live demo, so it shows I'm confident in my software. So here's kind of a place. This is in Yorkshire, near the city of York. If I want to find out what the coverage would be if I was to place an antenna somewhere, you can do a thing called a viewshed. If I click on the map, it does a viewshed. That did about 1 million line of sight tests to perform that calculation, and I can do 1 million more. And if I made my antenna lower down, you can see that it has an effect. And if I change the coloration on the map, you can actually see there what is impacting on the line of sight. So this is not optical line of sight, this is wireless line of sight. I won't explain the difference, but it's very important for those of us who do work in the wireless industry, because radio signals don't, they have not a mass, but they spread out. And so it's important to understand that. So that's an example of if you like, what a viewshed looks like, rendered over a huge area. And we can actually produce 300 viewsheds per second on a single little server. The slow bit on this one is just rendering it on my web browser. So we can actually perform 1 billion line of sight tests per second in order to be able to do this stuff. We can then translate that into sites and access points and coverage. So here's a map, here's a town. If I had an access point on this map, let's say I have a sector antenna on the 5 gigahertz band, so I'm doing some long range stuff, maybe 30 megabits, 50 megabits, up to a few miles. What would that sector antenna see? And it does a line of sight test to every address on address base. And in this case, within certain wireless parameters, this is what it's showing. Green blobs means that it can see the property. Red dots means that it can't. And I can see the profile, and you can see there the ground is in green, and the other lines are surface data, things like buildings and trees and hedges and bits and bobs like that. And I can download this as a marketing list, so I can work out who I can sell to. If I want to do some gigabit stuff, or if I want to work out where fibers are, let's say I've got a fiber path running through Yorkshire, I can do so. In fact, I've got fiber path map there for most of Britain. Let's have a look where the splice points are, because I might want to build on top of a fiber network and just extend it with a bit of with a bit of fixed wireless. So let's say there's a splice point there. Let's bung an access point on it. Here's a tower. Let's say it's a 10-meter telegraph pole, nice and easy, cheap to build. Put an access point on it. I can define some characteristics about it. Let's put that, let's assume it's a teragraph thing running at 60 gigahertz. And I'm running on a millimeter wave band here, press test coverage, and it will show me the addresses that can see, which in this case is absolutely none. So let's say that's a rubbish place to put a tower. Let's say we wanted to put it in the middle of this housing estate. Test the coverage there. All of a sudden, I can see what I can deliver gigabit speeds to, 255 premises, and I can download that as a list and know exactly who I can sell gigabit internet to. And there, ladies and gentlemen, I would like to thank you for your attention, and I will draw my presentation to a close. If you have any questions, I will be delighted to help out.
Wonderful. Thank you, David. Very impressive.
A breakneck speed tour of wisdom. Continuing the sort of the design tools, Michelle, are you okay to go on next? Excellent. There you are.
Fired up. Okay, so do you see my screen?
Yes, we do.
Okay, great. Hi everyone, I'm Michel Ayoun. I'm a project manager at SETIX, and I will try to keep it also very brief. Okay, so a few words on the company. SETIX is a telecom consultancy company active for more than 20 years in high-speed broadband networks. We have two main activities: telecom consultancy with activities such as assistant to owners, project management, and so on. And we're also a software development company. We have a software called SETIX Star, which does automation design for FTTX network, which is the core of the presentation. Just some of our clients here are direct or indirect clients in UK and Ireland are involved in commercial and or publicly funded networks. And in particular, STAR was used in the context of regional or country level tenders, where it's probably one of the only products in the marketplace able to produce realistic HLD in a very short time. Here is a few clients in France, which is our domestic market. CETIX is a French company. And in France, we have all operators involved in open access networks for rural areas. And I thought it was interesting to point it out. So let's go to the core of the presentation. Automation design here can help produce all type of network studies, from strategic planning to detailed design. And as you can see on this graph, it can interact with feedbacks from field surveys. So the difference for those of you who are not familiar with all these different type of design, strategic planning is the phase where you decide where to build and what type of network to build by comparing, eventually comparing different type of scenarios, different type of network architectures, and different type of network architectures. So one of the examples where we did that was for the first phase of the Estonian network, where we help that specific operators with the help of partners to decide on a scope and on an architecture by keeping under a per premise budget of deployment. So that's kind of a strategic planning. Now, when you have defined that scope, you move to HLD, where you know what you want to do and you want to create a first phase design to have an estimate of the cost and the quantities. An example of that type of network is what we did for NBI in Ireland, for example, for the Ireland tender. And when we have that, you move to detailed design. Now, with our software, you do all of that with the same tool in the same environment, having the same type of integration with external data sources and data targets. Now, how does that work? Automation design, as I said, can be used to do various type of work. It needs data, so it needs geographical data representing mainly infrastructures. That's what you want to use for the network. It needs engineering rules and equipments. That's how you're going to build it and what you're going to build on the network. And when you have all this, you can just run design automation that will produce a first level, let's say HLD design. Now you can export that directly to get an HLD design and have a bunch of exports, what I'm going to talk about in a minute. Or you can refine that design by having manual interaction directly in the software itself in an embedded map. And you can also update that with field survey data when you do field surveys on the field and get more refined inputs. What type of data do you get out of that type of system? 4 types of data. The first type is analytical files and reports. So you have bill of quantity, bill of materials, bunch of financial analysis, high level view of the network. You also get a full network model, which consists in GIS data network model. It contains all the elements of the network with detailed attributes of logical, physical, financial information, topological information, and so on. The 2 other things you get are a bunch of files meant for human viewing and human understanding on the network. So that typically can be cable diagrams, splicing plans, fiber optic routes, and so on. So these are meant not to integrate with the system, but for the people working on the network to make sense of all of this and to view, check it visually. And the last thing are technical files for integration with other systems like PNIs, databases, and so on. Okay, what type of service can you get? So we have a model where it is up to the client to decide if they just want to have the results of the software, and so we can provide everything. They just drop some data on us and some rules, and we do the studies and provide with the results. all the way to the client uses the software in complete autonomous, and we just provide the software and the training necessary for them to take advantage of its capabilities. And there is a middle ground where they run, the client runs a pre-configured software, and we deliver everything on premise. A pre-configured software, a training that focus on their specific needs and their specific type of network, and we help them maintain that along the way. So it's a middle ground here, and a lot of customers are actually interested in that type of way of working. A word on extended automation. So StaticStar is an automation design tool, and it can be integrated in a more complex automation environment. So we provide a full automation environment. We can provide a full automation environment where data from data source can be extracted, prepared, loaded into the software then launch the calculations automatically, and StaticStar can then integrate it into a target database and also produce, in addition to the standard outputs that I've just talked about, customized reports, customized analysis. All right. What are the benefits of automated design and planning? It saves time, obviously, removes the major bottlenecks, especially in terms of people. Save a lot of time, obviously, in design, network design. You can compare between various options in various scenarios very easily and in a seamless manner. It offers flexibility, so it can be integrated in a fully automated process. It's a Windows-based software. You have no third-party license necessary, and it provides detailed information. So you generate very detailed bill of quantities, bill of materials, and a lot of information of all the elements of the software. Okay, cable splitters and so on and so on. And that is it for me. I hope I wasn't too long. Not even 10 minutes.
Michel, thank you very much indeed.
Thank you, Michel.
If you could just unshare your screen, beg your pardon, then we can move on to Rob.
Sorry.
That's right. Well, don't go away though. We'll do the Q&A when Rob has finished the final presentation.
Excellent.
Which
Can
is
you see
straight
my
on the
screen?
screen. Yeah, absolutely. Woof.
Perfect. Very good. Good. Okay. Thank you, guys. So I'm going to whiz through this one as well, conscious of time, and want to get to some Q&A at the end. I'm going to talk about a solution called Asset Hub, which is something that myself and some colleagues have been working on for, well, probably a number of years now, actually, under the guise of, and my screen isn't moving on. There we go. Hub Group. Several colleagues and I have got together. We are open access specialists. We consider ourselves wholesale specialists, and we've been working on asset mapping and business cases for local authorities, LEPs, road and rail. And we've been taking best practice, best in breed solutions from other countries and developing them for the UK. So just a quick point about asset reuse. There's a whole bunch going on, as everybody knows here in the UK. The government has a particular move towards outside in and funding and gigabit coverage and nationwide full fibre coverage from various times, and to be a world leader in 5G. What a lot of these commitments need is the ability to reuse existing assets as much as possible in order to speed up deployment and reduce costs. And from the regulatory side, we're also seeing a movement now from DCMS via Ofcom for the access to infrastructure regulations. We spoke about that briefly earlier on. Why are people not reusing assets more than they should be? How easy is it to reuse an asset? And can this be standardized? So the Asset Hub, which we'll come on to, is a way of visualizing existing assets that may be available and provide the interface to access them and contract with the asset owner. So what sort of assets are we talking about? Well, there's an awful lot of public sector owned. So there's approximately 7.5 million street lamps in the UK, particularly useful for 5G or Wi-Fi. There's around 60,000 public sector buildings, some of which are fairly tall, or at least multi-story. Public sector themselves own probably at least 40,000 kilometres of fibre and duct, and private sector owns hundreds of thousands of kilometres of fibre and duct. There's a lot of mobile masts out there, but there are a number of problems that cut across all of them. So where are these assets is the key one. Who owns them is also a problem. How do you find them and how do you access them is another one. And what is the process for accessing them? What are the standard specifications? Every asset owner seems to be different. Every local authority has a different process. So how do you contract? And ultimately, how do you reduce the cost of your build, and how do you potentially avoid overbuild by others? These are all questions that have fed into the thinking around this solution. But what we've done is we've taken knowledge and experience from Scandinavia, and in particular SSNF. And I'm not going to pretend to pronounce what that actually means, but I think Anders will probably be able to do that better than I. But essentially, it's the Swedish CityNet Association. And they went out to the market a number of years ago to fix this problem themselves. So they have a platform in use today, and that's the one we're using and planning to bring to the UK. And it's delivered by Digpro, who we heard from earlier on. But what happened that was critical in Sweden, certainly, is that the industry got together and agreed some standards. That means standards regarding products, services, and SLAs for accessing certain assets, whether it's passive or indeed active assets as well. So standard processes were agreed and commercial contracts were agreed to ensure automation. And that enabled platforms like this to come about, where now it deals with thousands of transactions per month on the asset side. And just a quick glance at the depth of the work that they've done over in Sweden and Scandinavia. They've created a whole bunch of framework agreements, technical and service specifications along different product sets that we can see here. I won't bother dwelling on this too much, but this is the point that we're at in the UK, I believe, that we need to at least agree on some level of standard in terms of products and specifications and service levels. Pricing will always be an issue, I think, and I don't pretend that everybody's going to agree on price, but that will come later, I think. So some of the key features of what this can enable. So it's a cloud solution, obviously, accessible via a web portal or an API. It's got different levels of user management, secure access, and it can essentially aggregate multiple different layers of asset data from different asset owners. And then what it does is standardizes the access to those assets. So it'll manage a complete inquiry, quote, order and contract process, dealing with each individual asset owner underneath and forwarding on the inquiry to that asset owner to allow them to either automatically respond or to come back with a bespoke quotation. And then the usage of the asset then gets tracked on the platform. And you can probably see that as it builds up, the number of assets that are on there makes it suddenly a lot more useful to people who are building networks. So for public sector, there's a particular benefit to them in that it can effectively take away the pain of dealing with the ISP and independent network operator community who may want to use some of their assets. They don't have the capability, they don't have the technical know-how to deal with the inquiries, so the platform can take that away from them. What it also potentially does is helps them generate revenue from their assets, which they currently either don't do at all or don't do very well. It's also suitable for private operators, so it kind of doesn't really matter what the asset is. It standardizes access to an asset. So if a private independent network operator wants to provide dark fiber access on its network, this is a mechanism that can do that in a standard way across the whole country. We originally tested this in my time in Network Rail, managed to map about 340,000 assets, including sort of bridges, ducting, fiber, overhead stanchions, etc., and created some standard products and then demonstrated that. And we're now developing it further in one of the 5G testbed locations, which is the Dorset one. So we're mapping lots of different local authority assets and some private network assets. Who would use it? Well, public sector asset reuse. We know that 5G needs more structures, and there's loads of street lamps and buildings that could be used for it. Utility companies, again, going back to the ATI, mapping of underground assets, making them standard for people to use, a single interface. It could be MNOs or their aggregators getting access to new locations or land or mast buildings, etc. The property owners, building developers, and of course the independent network operators. All in all, reducing cost to build and speeding up deployment. So that's a very quick whiz through. I've got one final slide, which is possibly a view of what the UK could look like in 2033. This is actually what London looks like now with all the different fiber networks that are there. It's actually not all the fiber. There's no BT fiber here, but there's a bunch of different operators, and you can see that, you know, this is probably something that DCMS wants to happen everywhere by 2033 or by 2025 if they can. But that's the desire, that's the plan, and that's what we're working towards. So thank you for your time. Hopefully I've saved a bit of time, James, and enabled some questions. And you're on mute.
You're right. Thank you very much. I was on mute. Excellent. Right. If we can get all of the panelists to switch their cameras on if they can. Then that should give us everyone on gallery view. So if we do have any questions, then let us know, preferably on the Q&A if people can. Where do we start though? It's been kind of quite an afternoon. We were keen to look at the design issues around all aspects of gigabit networks, and as we were starting to develop the agenda for this, realised there really was quite a lot involved, from the issues of you know, what's going on with wireless, to the wholesale access, to asset reuse. There just doesn't seem to be any kind of end to what we need to do. Sorry, I'm distracted by a question coming in. No, that's okay.
It's just Arthur coming back from, he had to leave his office.
Any of the panelists got any comments, any issues?
I think for me, there's clearly a huge amount of development that's gone on in the wireless space, which is really encouraging. And, you know, James, you and I have heard some of this stuff a little bit before, but I know there's been some feedback from some of the audience about, you know, the changes that have happened in the wireless industry and how it can really help towards creating the gigabit nation that you know, DCMS and the government want. So I think it has a very strong part to play. It's good to see.
Yeah, I'm particularly interested. One of the things that I've been looking at in North Wales is the issue about how to manage transport corridors. North Wales, the transport corridors exist because there's a great big port on Anglesey. It's one of the busiest ports in the UK, and that's what means that they've got the A55 is a decent road. Otherwise, it wouldn't be. But we need to manage transport along that. I was talking to the port operators, and they pointed out that their car park is not big enough to park all the trucks that will go onto a single ship. And so they need to be able to manage the transport along the whole of the route of that A55. I was thinking you might use something quite nice like, sort of LP1 just to, sort of do that. But someone pointed out that although your signaling is quite small, as soon as it's starting to move at 70 miles an hour, or let's call it 60 miles an hour, then it all gets a bit more difficult. So Andrew, is that something that you would look at sort of gigabit as being something that, sort of the 60 gigahertz as being something you could use?
So everything scales really nicely with bandwidth. So things that kind of are fast in a narrow band become sort of slow motion when you've got channels that are 2 gigahertz wide. I think one of the aspects that is interesting for wireless, that I find interesting, is how you invest in it. Because if there's a significant investment in infrastructure, it's obviously got to be something that has a decade of lifetime and ideally much more than that. And then it's difficult to avoid the question of doing anything that isn't other than fiber equivalent in some way. And that's, to me, why it's worth putting the effort into some of the 60 gigahertz technologies or the even higher frequency technologies. That's not to say that there isn't a role for other for a whole point of 5G, in my view, is that it's connecting up lots and lots of different technologies that are tuned to the application. And maybe the key there is to do things in a way that's modular and flexible. And that's has implications for the wireless technologists if they have to fit in with ecosystems that allow that flexibility.
Okay.
Can I make a comment and just raise a small issue? So first of all, thank you for inviting us to participate in this. I think the huge amount of innovation and ideas in terms of solving some of the problems, I find really quite inspiring over the last couple of hours or so. My issue is actually I have another meeting I have to go to in a few minutes. Because I booked our time till 4:30. So if there's any questions for Huawei, either myself or Arthur Chen, then please ask now, because I'm afraid I'm going to have to drop off very soon.
No problem.
That's okay.
I
think, to be honest, that we have clearly, judging by the lack of questions coming in on the Q&A, everyone is feeling slightly overwhelmed by the range of topics that clearly we need to consider. So I think probably we're going to bring this to a close. If anyone has got any questions, any issues for Inca, for any of the members of the panel, then you know where we are. You can send those through. So I think, final thank you to all the panelists, Rob.
And particular thank you to Huawei and Cetix for sponsoring as well. Thank you for making the event possible. It's been very helpful. If there are any other questions, please shout them out now. But I don't think there are. When's our next session? We've got a policy and regulatory session coming up tomorrow as a summary, and then next week we've got the switching and wholesale special interest group meeting. So do jump on the Inca website and have a look at those if you're able to attend. I'm not sure they're open to all actually, but no, thank you very much to all the speakers. Thank you to the sponsors, and unless there's any other questions, I think we can probably close it there on time for once. I think, James.
Thank you.
Thank you.
A challenge, yes. Thank you very much, everyone.
Thanks.
Thank
everyone.
you.
Thanks,
Thank you.
everyone.
Bye.
You still in your car, Lloyd?
I am. Yeah. Oh dear, unbelievable. I'm good. Okay, I've got to go to my next meeting now, guys. See you later.
All right. Thanks, Lloyd. Cheers.
Bye.
Bye.
Oh, I thought there was a button I hadn't pressed. Thank you. It was,
Thanks. Are you still there, Jill?
Hi, Andrew.
Thanks, Jill. Cheers and bye. I'll try again. I'll try and leave again now.
No problem.
Bye.
I think you have to close it, Jill. I don't have the privilege anymore.
No?
No, it just says
You've
leave
not
the
got an
meeting.
end button.
Not end, just leave.
Ah, okay. All right then. I usually wait until sort of the last dregs are there.
No worries.
Okay.
Okay.
It went fairly well, didn't it?
I think so. Yes.
Yeah.
Bit of a mad rush, but some overrunning presentations. But
Yeah.
there was a
Yeah.
lot of content.
There was.
Yeah.
Yes. Yeah. We had, hold on, 63 at the start, and we ended with 44. So we had quite a few no-shows. The majority of them were Huawei's guests. Yeah, we didn't have many that weren't ours. No,
So it's
even
just-
that one.
Oh, it's just you. It's just us two now. I just kicked off the other attendees that were still there. So
Okay.
yeah. No, I thought it was good. Bless Arthur. He was. It was about 11, half 11 at night in Korea, where he was.
Oh, was it?
Yeah. So
Crikey.
they sent me a message saying he's actually been kicked out of the building he was in, but then he obviously left and then rejoined via mobile.
Oh, bless him.
Yeah. So that was good. Good of him.
Oh, yeah. Okay. All right. Right. There's an important one that you need to read on your emails for William Black, OpenReach. James has responded, but
Is this Chair or Rob?
I think I put it to both.
Okay.
Yeah, I think I put it to both. It's what's it entitled? BDUK Supplier Engagement.
Oh yeah.
It's entitled.
Let's have a look. William Black. Right.
I've also got to contact James because Mike wants us to move the meeting on Friday.
What meeting on Friday?
Proactive PR. James is
okay.
With those, so that one.
So OpenReach wants to get together with us to talk about concerns about BDUK's proposals. Okay. Yeah, I mean, I'm happy to have a chat with them. I'm not so happy to agree with them.
No.
So I'll just say, yeah, fine with me.
Yep. Okay. Which one of you is going to reply, I suppose, is the... Or do you want me to reply and arrange a call?
Yeah, if you could, if you don't mind.
Yep.
Is that okay?
What? Yeah, that's fine. What availability have you got? When would you like it to be? And I'll check with James.
I'd like it to be in 2 months' time so I can have a break from stuff. It's just been nuts lately. Let's have a look. Tuesday next week there's a few gaps between 10 and 2.
Hold on, Tuesday is the 7th,
Yeah.
10 till 2. Yeah.
Wednesday, let's say 11 till 3.
7th, 8th. Yep.
Thursday, anytime up till 2 o'clock.
Right. Okay, that'll do me.
That'll do. Yeah.
Yeah, that'll do. And I'll check with James.
Yeah. Okay.
All right.
Lovely.
Thank you very much.
All right. Thanks, Jill.
See you later.
Cheers. Bye.
Bye.